Isa, you revised all this, right? The chemical kinetics.
Yes.
Uh, Fifth is D. Sixth is also D. Seventh is your B, not C. I'll explain this. And then comes your BB, that is correct. This is also B. This is also B. Okay. So I'm going to explain the seventh one first. Then you are going to see seventh one. So see, very simple it is. First of all, what we need to do is write the rate of reaction in terms of stoichiometric coefficient for this half of, you know that N2O5, D of N2O5. Basically, we can write divided by dt. That will be equal to plus 1 by 4 d of 4NO2. That means NO2 divided by dt. And this will be equal to 1 by 1. That means either you are going to write it or not. That doesn't matter. DO2 upon dt. Now, according to the question, the rate that is given as minus d of k into N2O5. That means we can write half of k N2O5. That will be equal to d of NO2 upon dt is written as 1 by 4 is there, k dash N2O5. And this will be equal to k double dash N2O5. So we need to establish a relation between these two. You can easily see that 2 to the 4, I can do this, and this will be equal to k dash will be equal to 2k. I can write like this, and k dash and k, I'm going to equate these two equations, the first and the last. So it will be equal to k is equal to 2k dash, or we can write k dash is equal to k by 2, k by 2. So I equate first and second, then second, first and third. So we can write k dash is equal to 2k, which will be equal to k double dash, and that will be equal to k by 2. So that's why this is the answer. Is that clear? Please go for question number 10. Correct answer. Just wait a minute. Any answer? So 11 is D, that is correct answer. 12 is also D, that is correct answer. 13 is, no, 13 is not, 14. 14 is B, 15 B, D D B. Please write the question number as well, otherwise I have to be very D D B. You give the answer. Wait. This is your wrong answer. You have given D. Then comes your D again. 16B and 17 is B and 18 is E. This is also given wrong by you, right? Yes or no, Aisha? Can you match this? Okay, so the one which is wrong is your 15, and 15 says that for the reaction, you can see N2O5 4NO2 rate and rate constant. This is your rate and this is your rate constant per second. That means it is first order reaction. This is your first order reaction. Then concentration of N2O5 at that time will be very simple. So since it is first order reaction, so I can write in terms of reactant, and that is N2O5 raised to the power 1, since it is first order reaction. And you know that rate is also given, K is also given. So can't you calculate the value of concentration? So if I'm going to put the value as it is 1.02 into 10 raised to the power minus 4, and this is your 3.4 into 10 raised to the power minus 5 into concentration of N2O5. So it comes out to be 1.02 into 10 raised to the power minus 4 and divided by 3.4 into 10 raised to the power minus 5. So I'm gonna just divide this 1.02 divided by 3.4. So it comes out to be 0.3, and when you are going to solve it, plus 1 is equal to rate concentration. So you can see the answer is 3M, not D or something. Is that clear, Aisha? Okay, 18 is also very easy. If you are going to see, first order reaction is given, rate constant is given, K. The time required for 40 gram of this reaction to reduce 10 gram. Okay, very simple. Time required, so I can write T is equal to 2.303 upon K. K has a value 2.303 into 10 raised to the power minus 3. Log of initial concentration 40 upon final concentration 10. So log 4 it is, so we can write log 2 raised to the power 2. Log 2 raised to the power 2. So it comes out to be, you can see this and this will be cancelled, and when it will go up, it will be 10 raised to the power 3 into 2 log 2. And you also know that this can be written as log 2 can be written as 0.3010, you can take. So what will be the answer? 0.30 into 10 raised to the power 3. So it comes out to be 300 into 2, that is equal to 600 seconds. If you are going to be more precise, you are going to take the value of log 2 as 0.3010. So it comes out to be 6026. I think it's clear to you, right?
Yes, sir.
Okay. Are you done with this? Okay, let's go. 19 is B, that is correct. 20 is B, that is incorrect. I will tell you. Let's see. 21 is A, that is correct. 22 is A, that is also correct. 23 is A, that is also correct. 24 is B, that is correct. 25 is D, so this is wrong by you. And 26 is B, that is correct. So you have wrong two questions. This is 20. So see, this type of question is very important. See how you are going to do it. This is the reaction that is given, and also you can see this is your fast, this is your slow, basically, and this is the mechanism. Basically, this is the mechanism, and you know that the step is very important, like whether it is slow or fast. So you know that slow step is the rate determining step, right? The rate determining step is your slow step. So what I'm going to do is very simple. I'm going to write in terms of this slow step. Rate will be equal to k into x into y2. This is how I'm going to write. That means rate will be determined with slow step only, not with fast step. Now you will look at this and also will look at the main reaction, this. So in the main reaction, you can see the reactant is your x2 plus y2. And in your rate, you are getting x and y2. That means in this rate, you should have the reactant only. And you can see you have y2, that is okay, but x you have, which should not be here. The rate should be in terms of reactant of the main reaction. Now, with the fast reaction, what I'm going to do is very simple. What I'm going to do with the fast reaction, I'm going to write the K equilibrium, Kc or K equilibrium, you can take K equilibrium. K equilibrium can be written as x plus x, that means x raised to the power 1, product of one reactant. So I can write this as concentration of product upon concentration of a reactant. Can I write this, Aisha? Kc, Kp, if you remember. Mm. After this, since we need to eliminate this, so the value of x can be written as x square can be written as x2 into k equilibrium. So x2 into k equilibrium. So I can write x2 into k equilibrium. And then I can write x is equal to x2 raised to the power half into k equilibrium raised to the power half. Now what I'm going to do very simple, this x I'm going to put it here. So what we will get is very simple. Rate is equal to k. K will be as it is. X can be written as x2 raised to the power half into k equilibrium raised to the power half, and y2 is there, right? So rate can be written as, you can see that this is also constant, this is also constant. So I'm going to write another constant k dash, that will be equal to x2 raised to the power half into y2 raised to the power 1. Now what we need to do is order of reaction. Order of reaction is the sum of this in rate law expression, whatever is the sum of this. So what you will get 3 by 2, that means 1.5 order. Isn't it easy? Right? This is a very good question. Why you mistaken 25? Mhm. Is there any answer for 25 again if you are going to do? what will be the answer? How can C be the answer? Okay, I'm going to explain. Can I change the slide?
Yes.
Okay, so see, for a reaction between A and B, the order with respect to A is 2 and the order with respect to B is 3. So rate can be written as A raised to the power 2 and B raised to the power 3. Okay, the concentration of both A and B are doubled. That means I can write rate R dash is equal to K into K will be as it is. It depends only on temperature. 2A whole square and this is also 2B whole cube. So you can see 2 to the 4 and 2 to the 4 to the 8 and this will be A square into B cube. Now you know that K is already there and this is what? This is the value of old rate. So R dash will be equal to 32 of R. That means the new rate will be 32 times the old rate. So the answer will be 30. Can you change the slide?
Yes.
Done. No, very good. Both of it is correct. B and A. Now, you see, in the next class, we are going to complete this chapter. Most of the topic is covered, only mm, some of them are left. Do you have any doubt in this chapter?
No, sir.
Okay, so just wait a minute. Just want to ask this question. Very good. So this is it for today. In the next class, we are going to complete this chapter. Okay.
Okay.
Thank you.
Mm.